Okay, what you're looking at here is a video capture I did a while back for a gas meter that I was troubleshooting remotely. What you see here, the two signals, the upstream is in blue, and superimposed on top of it, the downstream is in red. I'm going to let the video advance somewhat, and I'll pause it here. And what you're seeing is that the signals are having a little bit of a hard time locking in. And let it go forward a little bit more. And there we just had a correlation Q. The correlation Q warning that we saw in this particular case is due to pulsating flow. Sometimes we'll see a correlation Q error because of a high electronic noise. In this case, I really don't see any noise on the baseline. It could also be that the high flow adjustment has not been set on this meter, but we did that already, so we crossed that off the list. You could have a bad signal to noise ratio because of low pressure, and then you would have what's known as synchronous noise on the baseline. Synchronous noise on the baseline occurs at the same frequency or has the same wave shape pattern as does the signal itself. So being that I don't see any of that on this graph, I'm going to assume that the problem that we have here is pulsating flow and the inability for the meter to keep up with the quick velocity changes. Now let's just watch this screen a little bit. Maybe I'll jump forward a little bit. There's the correlation Q. And a little bit further down here, we switch to a different window. And here's that other window. And we have an error for the flow velocity. And that's because they're not matching one another at all. I know it's kind of hard to see, but they're very different from one another. Let's see if I can advance this a little bit further. And you can see it's not consistent. It'll recapture itself for a while. Yes, it'll come into sync every so often, and then the alarms will clear, then they'll come back again. Now, if you keep track of how the velocities are tracking on the screen, I'm going to zip forward a little bit. You see there's large surges in velocity. And I believe that's what the meter is having a hard time keeping up with, is those high surges in velocity. See that there? And let me pause it here. Whoops. Anyway, what I believe that the problem is that we're taking too much time to process the data for it to be as clean as possible for the best measurement. And because the velocities are changing so rapidly, this is working against us. So what we have to do is we have to relax that processing by lowering what we call the dampening filter. Now, if you're familiar with the 1010 meter at all, we used to just go in and set the digital dampening to 0, And we used to use the graph to enable us to do that. For the FS230, we have to do this a little differently. We have a number of files that we can select from to load onto the SD card of the meter, and then just recycle the power, and that'll automatically set it to the filter that we want. And in this case, we want to set it to 0. So there is a file called 0.def, and that's the one we want to take and put onto the SD card, put it into the meter, and restart the meter. Now, if you open the front door, if you open the front door of the meter, you'll see where the SD card is located, and you can remove it and place that into your PC, and then just copy the 0.def file over to it. Now, once the file is copied onto the SD card and moved back into the meter, you want to hit the right arrow, go down to Maintenance and Diagnostics, go down to Resets, and do a device restart. And you just have to wait for this to restart, and once it restarts, everything will be loaded in, and you can take a look at the behavior of the meter again. And hopefully what you'll find, and you should absolutely find this to be true, that once you go back and look at your signal, it should be stable and not losing track of itself when you have those surges as a result of pulsating flow. That's it.